Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW. Let the team at Black Hills Information Security test your defenses. With over 10 years of experience in penetration testing, red teaming, and threat hunting, the testers at Black Hills will help you find the holes in your security before the bad guys do. The team at Black Hills cares about educating and sharing their knowledge by creating countless blogs, open source tools, and webcasts for you to learn more about the tradecraft of pen testing and red teaming. Visit securityweekly.com/BHIS to join their mailing list and view the latest blogs and webcasts from Black Hills Information Security. The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. Observe It enables security teams to detect risky user activity, investigate incidents in minutes, and effectively respond. Get your free trial at observeit.com/securityweekly. Welcome back, everyone, to Enterprise Security Weekly. We are currently running 2 surveys. We mentioned the 5 stages of automation maturity in the previous segment. You can go to securityweekly.com, click the survey link, take that survey, give us your feedback, and register for a webcast we'll be doing in November on that topic based on the survey results. I'd like to introduce our guest for this segment, Carter Manucy. Carter's been in IT for over 20 years, focusing on operational technology-specific issues over the last decade or so. Carter's been involved in everything from basic good business practice to operational technology to NERC SIP compliance issues, and the proud coin carrier of the beer ISAC. It's awesome.
Thanks, Paul.
Cool. Carter, welcome to the show.
Thank you, sir. Thanks for having me.
Nice to have you on. Matt is obviously also here with us as well. I think the burning question on my mind, Carter, is, explain, I guess, for our audience, set the stage for the differences between information technology and operational technology as it relates to industrial control systems.
So we all know with IT, a lot of the audience is probably familiar. Data is probably, your key component that you're worried about protecting and everything else. The difference is with operational technology, processes and availability are really the key drivers. Because behind a lot of the things that industrial control systems do, they protect against not only the equipment from failing, but also the safety from an individual standpoint, which you really don't have in an IT environment. You don't have those folks, a patch or an incident on the network doesn't necessarily cause a life safety event in most IT environments, where it certainly can in an OT environment. Lot of these process controllers just, those PLCs are really there to do a job. And if they're not able to do their job, equipment can blow up, people can get hurt or killed.
It's the difference between business operations, right, and the impacts of some problem to business operations versus infrastructure operations, which is controlling the critical infrastructure, power, water, gas for cities, towns, states, countries.
That's right, and that's where we're really concerned, of course, in those critical infrastructure areas, to make sure that we don't have issues from outside entities. And that's where the cybersecurity component comes into play with OT, is just making sure that those processes can run, they're not affected by outside adversaries or, showing up on Shodan and folks having their way with devices that shouldn't be on the internet.
Right. And it's interesting, too, we talk about healthcare technology as maybe a critical service, but the healthcare operations rely on power, water, and gas in order to operate. So it really is that lowest level of critical infrastructure.
Yeah, there's been a lot of talk with power being the most critical of the critical infrastructures. And everything goes back to power, right? We do rely in the power industry on other things. A lot of natural gas. You got to have natural gas to run some of the facilities, but they rely on power to actually keep a lot of the compressors running and everything else. So it's
Gotcha.
a circular argument, but
Yeah.
powers it.
Yep. Matt.
Now, a lot of IT vendors have been moving into this OT space and think that they can take their technology that they applied to the data center and now say, oh, we can do this in the operational environment. But that's not really the case, is it?
There's a lot of instances where vendors have come in and tried to apply techniques, and even individuals that are used to doing scanning or something in an IT environment. They come in and they try to stand up their scanning instance into an OT environment, and all of a sudden some very weird things start happening. Controllers start flopping over because they don't have the network availability that they thought they were going to have there. Processes start failing, things lock up. It's just a different environment. So the tools that are used and needed in the OT environment are really specific to that environment. They have different protocols that run on the networks. The devices are a lot of times very old and not designed to be, shall we say, manhandled by a huge network and Nmap scan. They just can't handle that kind of thing because they're designed for a function, and if that function doesn't happen, then they give up pretty easily sometimes.
Yeah, it seems to me it's in the OT space. Well, there's very much I don't know if it's a disconnect, but it's a very different culture. And I think oftentimes if you're in IT and in security on that side of the house, the OT folks, you have a tough time communicating with them and earning their trust because you haven't worked in that OT environment. Carter, can you kind of speak to that somewhat? And what I want folks to come away from this interview with are some different levels of understanding of what it's like to be in OT and why there's sometimes that disconnect.
I think one of the big drivers that I've found throughout the years is the fact that a lot of folks in IT are used to change being a normal thing. It's dynamic, right? You don't know what's going to happen day to day sometimes, and you have to react quickly and stuff like that. In the OT environment, change usually can translate into non-availability or processes failing or something to that effect. So a lot of the folks that are in the OT environment are pretty adverse to change. They like things to run the way that they're used to running. Mm-hmm. They like to know exactly what's going to happen day to day, because those unexpected things that pop up can sometimes lead to downtime and other real bad days for them. So when a lot of folks from the IT space come into the OT space, they try to bring that history that they've had with them, and it just doesn't match well with a lot of the operators and the folks that are in these facilities. They want their consistency, and that's a key message for anybody coming into the OT space, is to check what you know at the door and come in with a fresh mind, because you've got to learn a new environment. This isn't the way you used to think. You can bring some of your experiences forward with you to solve problems, but don't try to walk in the door and solve all the problems immediately, because you really won't understand this environment until you spend some time in it.
Yeah, Matt.
Right. Yeah, so I have a little bit of experience. It's old, but back in the days when I worked in nuclear power, change would happen during an outage. And you would spend months, 18, 24 months planning a project, right? You would be doing software updates and having them sit in a staging environment. You would start getting I/O ready to go to feed this new software program. But none of that work actually happened until the plant was down. You took an outage, it was a refueling outage, and that's when you did all your major changes. And you would get through the changes, you do all your testing as all the other maintenance activities were going, test it, and then everything would come up. And that environment would not change for another 18, 24 plus months until you're ready for another refueling outage. That's just the way we worked back then. So to your point, between those, when the plant's running, you like the plant to be very static. You don't want change. And you only make those changes when those plants are down, typically.
Well, because there's no variance for or tolerance for any variance in uptime, right? And when I think of DevOps, a lot of the really great conversations we've had make me think, after hearing this, it totally does not apply at all. Because in DevOps, you're constantly pushing forward, and if there's a problem, you live with that problem until you can push forward again. And sometimes that could be a day, could be hours, could be minutes, right? But the risk calculation is we're going to live with that that issue or that problem until we can just go push another release and then find the next little issue or problem and then go push another release. When you that doesn't translate to OT because there's no variance there. It can't be down. It has to be static and stay there, right?
And it's there's a story that's been floated around out there with a virus that's been on a network for since actually it was done in the inside the quality control before it even came onto the plants, and so they've had this virus they've been living with, and it gets discovered a number of years later, and then all of a sudden they say, hey, we've got this this problem. Let's go clean it off. And a lot of people, whoa, it's been running fine for over a year. Let's wait until we get to our next outage before we even do anything, because maybe we need that virus. I don't know.
Right. Yeah, right down to even malware running on the systems. That's really interesting.
Because plant operators, when they're sitting in the control room, are looking for anomalies in signals that are coming back to them. And in the one variation they can't have when running the plant is changes to the environment that could also create variation in the signal. Because then their procedures of how they address high pressure or low pressure or temperature, et cetera, go right out the window. There's no standard operating procedure to follow anymore to keep the plant in a safe operating condition. And I don't think a lot of people from the IT side really understand that when it comes to OT and how those systems need to run.
You also have a difference with the reaction of a IT system. If you have some malware, some bad network traffic coming through, you want to stop that at the door. You want to stop it at the endpoint. You want to make sure that you isolate the endpoints. We have a lot of stuff with NAC and everything else. In the OT environment, a lot of the tools and stuff that we use to monitor and identify anomalies and everything else are actually done passively. We're done through network taps and stuff like that. We watch the data coming across the wire, and if we have to react to it, we will. But you don't get in the middle. You're usually not reacting like an endpoint normally would on a typical Windows PC. I've had many people tell me that these machines might have Windows on them, but they're not Windows workstations. These are devices that are used for critical operations of the plants, and without them, they cannot operate a lot of these facilities.
Yeah, you have old versions of Windows XP and embedded Windows systems out there. You can't patch those guys because you don't know if it's going to impact the devices that are running off that. Carter, quickly, when I was in nuclear power, we made very distinct network decisions, right? We had a lot of fiber into the plant that brought a lot of the I/O back to the data center, which was feeding the control room. But then there were no connections from the outside world into that data center because we didn't want that internet connectivity and that other stuff. Has that changed over the past 20 years? Are there more of those physical connections in these plants to the outside world that create some new issues that I don't think I was aware of back in the day?
There's for most generation facilities, there's going to be some kind of connectivity you've got. You have to feed data back to a control center as far as what rate you want the facility to run at. You have to feed data back into the grid as a whole to make decisions on how to compensate for load that's coming around. So those communications are almost a majority of almost every single facility out there. There's also connectivity from OEM partners sometimes that want to monitor the unit for anomalies or uptime or other issues that they want to make sure that they're on top of because they're the ones that built this unit. They're going to know it better than anyone else. Then you come into the business needs, right? So now we've got a lot of business decisions being driven off of the facility's runtime, the facility's how efficient it's running, a lot of these other types of things. These are the types of business decisions made by historian data coming out of the facility. Mm-hmm. But I think that there's been a lot of inroads made with technology such as data diodes and some other things that also help keep the connections that don't need to have two-way communications there. But there are other connections that do have inbound and outbound connectivity. But we're very tight about those things. We're not, this stuff doesn't go out on live on the internet. We're not controlling it from Starbucks down the street or what have you. But a lot of that operational data does need to get out so that folks can view and make decisions outside of the facility.
I do remember an interview that we did with Waterfall Security that made, still makes, that diode technology that only allows traffic out. And it's actually a physical, in the hardware control that only allows data to come out.
Yep. Those are neat little devices. They have their place. Some people think that data diodes are a solution to everything. I think they're a solution to specific problems. And they certainly work in some situations. They are difficult to set up. They do their job very well, and they're frustrating for some folks. But they certainly can allow you to get alerts out, get SEM traffic out, logging, all those good things, so you can actually monitor those devices in a safe manner and not have to worry about that connectivity coming back if you do have some kind of centralized SOC or operations that's watching a bunch of different facilities. You don't want to create that pathway back for some adversary to utilize against you.
And now that's in a wired scenario. What about wireless technologies? I know they're in use in certain sectors in ICS. Do you have experience with that? Because obviously, if it's wireless, it's difficult to control that inbound, right? Because it's literally in the air.
Wireless is interesting. It's not the same at every facility. Some manufacturing facilities aren't nearly as process bound, or they're not as an RF bad environment as say a power plant could be. So you might have more wireless in certain types of environments where you have less critical operations. You also have the wireless from just the microwave frequencies that might talk to facilities that are out in the field that they need telemetry back from and stuff like that. Generally, wireless is only used at most of these facilities for administrative needs. If you want to check if you're doing rounds and you want to have data on a handheld that has no connectivity back to the actual operations facilities, they'll do that sometimes. But generally speaking, folks stay away from wireless just because it can be unpredictable and difficult to work in RF adverse environments, shall we say.
Also very important to make sure someone hasn't, for example, plugged an access point into the network that's supposed to be separate from everything else. Yeah. Essentially opens it up, right?
Those rogue access points are I wouldn't say they're a problem. That's something that you hope you train through policy and procedure. The folks don't use these types of things, and keep your personal stuff personal, and don't bring that to work, and don't expose this OT network to outside connectivity through that. But there have been instances where that have happened. There have been instances where folks have had rogue access points plugged in and they forget about them. Maybe it's got 4G plugged in for a vendor to come back through to test something, and then it gets left behind or something. That has happened. So
right. Go ahead, Matt.
I was going to say, if we think about environments where you have both, I'm curious, how do you approach the problem of the integration of IT and OT? Is it two different systems that stay isolated? Is it two different systems that have to integrate together? How do you start to address the uniqueness of IT demands with OT demands and figure out how to manage them more holistically? I'd love some of your thoughts on that, because I think that's one of the challenges with some of the CISOs I've seen that traditionally came from the IT side, and now they own a bunch of plants, and they don't know how to address the OT side. What do they do with it? Any guidance on how you bring some of this stuff together?
I think you have to have the right tools. You have to have the right applications that support both concepts. The ones that are designed and built from the ground up to support OT technologies, OT protocols, OT facilities, either have them feed into a centralized SEM that could give you visibility, or another tool that could give you visibility, or perhaps you're fortunate enough to work with a vendor that supports both IT and OT at the same time because they understand both worlds, or perhaps they acquired product from both sides and that allows you to utilize those facilities. It's troubling though, and it's difficult to have that everybody wants a single dashboard, right? They want that single pane of glass they can see everything from. But that creates more problems. Now you're merging networks together. You're collapsing data into a single system. You're creating monsters sometimes that you have trouble controlling after they're complete. So I don't think there's any kind of a silver bullet here. I think there's a lot of progress that has been made in the space. I think there's further progress to be made. But just watch out for some of these leading vendors, and spend some time with them and talk with them about the stuff that they have available and what they're doing in the space. And, go to events like S4 and learn about this stuff. And you might come away with some great answers to problems like that.
Yeah, I know a number of those startups that are really specific on the OT side. I think one of them's been acquired by an IT security vendor. So I think there might be one that I'm aware of that can actually attempt to do both. I don't know how well the acquisition has been integrated in. But you bring up a very good point, right? Is that the solutions in OT are going to be very specific to the protocols running in the operational technology side of the house. And so you're not going to take a traditional IT security solution necessarily and try to put it there, because part of it's a lack of visibility. I can't even see, a number of the protocols that are running to even do anything with it. Put that aside. But then the integration component, I think you bring up a really good point, is, do you want to collapse? Do you want to integrate those networks? Do you want to collapse that data, or do you want to keep them separate? Do you want to manage these as two separate environments and keep a level of isolation? And my guess is that's going to vary industry to industry and company to company at the end of the day.
Right. In the compliance space, NERC-CIP dictates that we should not be mixing these types of environments together. That's the approach that we take, but that's not the approach that everyone takes, because sometimes in IT, you get a lot better bang for your buck if you've invested in a singleized storage system, storage array, a large rack of devices to do your entire virtual environment. It's hard to then justify a business cost to duplicate that or make it again for just the OT side of the house. So that's troubling. But I think the other problem that we've got is a lot of these vendors and applications, even down to the firewalls, they don't understand at layer 7 a lot of the protocols that we need to filter out these commands back and forth. There are some that do for some of the older Modbus technologies and stuff like that. But if you get into a proprietary protocol from a specific vendor, it's difficult to find somebody that can filter out that data and only allow those commands to go through at layer 7 that you actually want to go across the wire versus those that are just flowing normally or perhaps are there maliciously.
Yeah,
Carter,
protocol. Yep, go ahead.
Sorry,
Paul.
I was just saying, what advice do you have for enterprise IT security folks to come up to speed and familiarize themselves with the culture, the mindset, and the technologies that are used in OT environments?
I think a lot of that comes from training and from being on site, and that's what we need in this industry. Is we need more people that understand both the IT and the OT environments. Mm-hmm. We're having trouble with that right now. There's not many folks out there that understand both environments or work well with them. And I think those people that do start to come up to speed get pretty brought into the fold pretty quickly and are valued, I'd say. So spending time either training or going to events that focus both on OT or OT IT capabilities. Spend some time with partners like SANS and stuff like that can help you out.
SANS has a couple of mixed events that they do. You have attended those in the past, and you mentioned S4 already. Yeah,
those are some of the big ones. And then, a lot of this space also drags folks into the compliance and NERC-CIP stuff, which, everybody wants to keep an arm's length away from. But there's good stuff there too. And there's good need for people that understand how all this stuff plays together and from a compliance point of view, so you can actually stay compliant with those standards.
It'd be a great segment for Security and Compliance Weekly, Matt.
Yes, definitely. Might have to have Carter come on that show and we can talk NERC-CIP.
See if I can drag Tim Conway into the conversation.
There you go.
There you go.
Awesome. Well, Carter, thank you so much for appearing on Enterprise Security Weekly.
Thanks for having me, Paul.
With that, we'll take a short break, come back with our topic segment for this show on vulnerability management and what you need to know to do an evaluation.